Hi, it's Mr. Adams from Midwood High School. This is a video on isomers. As we discussed before, isomers are substances that have the same molecular formula, but they have different structural formulas. Now we have here, right, in this example right here, we have pentane, right, regular pentane. And below here, we have two isomers of pentane. Now pentane's molecular formula is C5H12, right? I know that because it's an alkane, because it's only single bonds between the carbons. So the general formula would be CnH2n plus 2, which is on table Q, if I'm not mistaken. Now this guy right here, all right, it also has 5 carbons, right? But it's not regular pentane. Its family's parent chain is butane, right? And this carbon's at carbon number 2, so this is 2-methylbutane. Likewise, this guy right here also is C5H12, same molecular formula, but its parent is propane, and it will be 2,2-dimethylpropane. So these guys are isomers because these structures are different and they have different physical and chemical properties. Now, when you're drawing isomers, guys, be careful of simple bending, and this is what I mean. If they say draw an isomer of pentane, and you do this, and you bend it up, and then you bend it across, and you bend it up again, and you say to yourself, yay, I have an isomer on my hands. No, you don't, because you have to watch out for the fact that all the carbons are still continuous, right? So this will be, what, 5 carbons? 1, 2, 3, 4, 5. Okay, all the carbons will be still continuous. So you don't have something that's different from pentane originally. So you have the same guy in your hands, you just bended it up. Okay, so what you have to do, guys, is make sure you move the carbons around to the point where you know when you name it, right, that you have a different name. And when you have a different name, okay, but the same molecular formula, you know you have an isomer on your hand. So watch out for simple bending. Make sure your name is different in terms of getting on drawing a isomer. Okay. On table R, people, okay, there's some nice information. You can do isomers within the same family, or you can do isomers between different functional groups. For example, alcohols and ethers can make isomers of each other once you have the same number of carbons, oxygens, and hydrogens. For example, this guy right here is propanol, right? All right, it has 1, 2, 3 carbons, right, with the OH. And if you look over here, this is what? Methyl ethyl ether. Okay, that also has 3 carbons. And if you check carefully, you will also have the same number of carbons, hydrogens, and oxygens. Okay, this what is it? This propanol has 3 and 2, what, 5, and 3 is 8 hydrogens. This guy in the bottom right here, methyl ethyl ether, also has 8 hydrogens, and they have the same number of carbons and oxygens. Likewise, folks, these two guys right here, aldehydes and ketones, they can make isomers of each other once you have the same number of carbons, hydrogens, and oxygens. For example, if I have this guy right here, I'm going to do this. 1, 2, 3, 4, 5 carbons, and I have right here, okay, a ketone which is called 2-pentanone, right? All right, I can transfer this carbonyl group to the end right here, right? Oops, okay, gotta remove that. To the end, 1, 2, 3, 4, 5, okay, and I just made an isomer of this ketone right here. This ketone is called 2-pentanone, but at this new structure I drew is an isomer of it, but now it's an aldehyde called pentanal. All right, so you can make isomers, okay, within the same group, or you can make isomers within different functional groups. Likewise, folks, organic acids, okay, organic acids and esters can also make isomers once you have the same number of carbons, hydrogens, and oxygens. But for example, amines and amides, right, will not make isomers of each other. Why? Because amides have a carbonyl group, amines don't. So you would not expect to make isomers between those guys. For example, something like an organic acid and a ketone will not make isomers. Why? because organic acids have 2 oxygens. Ketones, for our purposes, only have 1. So that's why I say here, folks, use common sense, because they can ask you questions and see which particular substances can make isomers of each other, which are best candidates. So you have to know that these guys right here can make isomers of each other. In terms of different functional groups, you must have the same number of carbons, hydrogens, oxygens, or whatever atoms in question. Okay, and that's it. All right, folks. As always, hard work plus sacrifice equals success. Hope this video was a help. Watch out for simple bending. Use common sense, and you're good to go.